So far, the sugars that we've seen have been in long, straight chains, and we've tended to draw them as Fischer projections. But some of the oxygens on those chains can wrap around and stick to one of the carbons at the other end of the chain, forming a ring. So first, before we show how the niceties of that in a problem, I wanted to show a video from YouTube about that illustrates how these straight chains can form rings when they're wriggling around in water. So here you have your straight chain. That's sort of like the sugar that we are used to seeing as a Fischer projection. You know it's a sugar because it has lots of OHs, polyhydroxy, and it also at the very top has that aldehyde, carbon double bonded to oxygen, single bonded to H. Okay, now all the bonds rotate and move around, and you can see that that oxygen there can attack the carbon with the double bond. Now, it can attack it in a couple ways. It can attack it from the bottom and push the OH up. Notice on the right side that OH is going up. Or it can attack it from the top and push the OH down. So let's see that again. It can attack it from the bottom and the OH goes up. Or it can attack it from the top and the OH goes down. Now, if the OH is going down, it's called the alpha form of the ring. And if the OH is going up, it's called the beta form of the ring. So, in question 15, they're asking you to identify a couple rings as either the alpha or the beta forms. Orient yourself by the oxygen in the ring. So here's our oxygen. To the left of that, you're going to have a little tail, a tail that's pointing up. So let's say this tail will be in yellow. To the right of that, you have a carbon, this carbon here, and you're looking at the OH coming off of that carbon. So here, that OH is going down. If the OH is going down, then it is the alpha isomer. Now technically, this is a standard way of drawing rings, the way they're set up here, where the tail is going up, but technically it's the OH and that tail being on opposite sides that makes it alpha. But a short way of thinking of it is to just look at the OH. If it's going down, it's alpha. Okay, let's play a similar game with B. Orient yourself by the oxygen. You'll notice that to the left of the oxygen, there's a little tail coming off of the ring, going up. Now, go to the right of the oxygen. There's a carbon there, and the OH on that carbon is going down. So again, this will be the alpha isomer, because the OH to the right of the oxygen is going down. If the OH were going up, it would be the beta isomer. But in this case, both of the OHs are going down, and so both of these are alpha isomers.